Now let's just talk about the next question, which says that prove that an equilateral triangle can be constructed on any given line segment. So in order to prove this particular example, we definitely need to do a little bit of construction. So let us suppose if I am taking this line segment AB, then using the Euclids postulate, which says that we can draw any circle with any center and of any radius, I am drawing two circles taking A as a center and B as a center. So let us suppose if I'll write it over here that using the Euclids postulate, which says that we can draw any circle. We can draw a circle or any circle of any radius with any center and with any center. So let us suppose if I'm drawing, taking A and B as nothing but the center of the circle. So let us suppose if I'll draw A taking as nothing but the center and AB as nothing but taking as a radius. So let us suppose if I'm taking B as a center, I'm drawing a particular circle over here, and using again A as a center and AB as a radius, again I am drawing AB as a radius. Remember, I'm taking AB as a radius. I am drawing a circle which is like of this form. So using A as a center, B as a center, AB as a radius, using the postulate, I am drawing these two circles which are meeting each other at a point which is called as nothing but C. So let us suppose if I'll join these 2 points, that is AC. Let us suppose this is my point A and this is nothing but the point C. So let us suppose if I'm joining AC and further if I'm joining this point B with C, let us suppose if I'm joining this point B with C, then this is nothing but the required triangle. This is nothing but the required triangle. As you can see over here, this is nothing but the required triangle. Now I just want to prove that this is nothing but an equilateral triangle. Now I just want to prove that the triangle ABC is equilateral. This is the thing that I need to prove. So let's just prove it. First of all, I can see that AB is nothing but the radius of the circle. AB was nothing but the radius of the circle, and it implies AB should be is equal to AC, because both of them are nothing but the radii of the circle. Because C is the point on the circle. C is the point which is lying on the circle. It definitely means that AC is nothing but the radius of the circle. Moreover, AB is also is equal to BC, because again this is nothing but the radii of the circle. So using the Euclids axiom, which says things which are equal to one another, are equal to one another. So using this particular axiom, I can say that if AB is equal to AC and AB is equal to BC, it implies AB is equal to AC, which is equal to BC. Hence, all the sides are equal to each other, and if all the sides of a triangle are equal to each other, it implies that the triangle ABC is an equilateral triangle. It is nothing but an equilateral triangle. So this is all about the solution of this particular example. But here is a special note for you. Here is a special note that Euclids have taken one such assumption as well, which is not mentioned anywhere, that whenever we draw two circles from the point A and B, as we have taken over here, then there exists a point C at the intersection of the two circles. So this was an assumed case which is not mentioned anywhere, that Euclid actually have assumed that whenever we draw two circles like we did over here, whenever we draw any two circles from the point A, from the point B, then there exists any particular point C at the intersection of the two circles in this particular manner. So we have used this Euclid's assumption over here as well. So this is nothing but all about the solution set of the example number 2 using the Euclid's postulate and the axiom.